Okay, so I'm going through C1 Jan 11. There should be a link to this paper already. Otherwise, go into the Edmodo group and find it through the sharing folder. Okay, so number 1 is the question on coordinate geometry, and it tells me that A has coordinates -1, 2, and B has coordinates 8, 5. So I like to write the coordinates down like that. When it asks me to find the gradient of AB for part A, I tend to think of it as dy by dx, which reminds me it's the difference in y's, the difference in x's. The difference in 2, 5, I'm going to get a -3, which I don't particularly want. So I'm going to do the b coordinates, take away the a coordinates, but it's the y's first. So 5 take away 2. Now, because I did 5 first, I must do 8 first as well. So it'd be 8 take away -1. So that's going to give me 3 over 9, which is 1/3. Okay, so that's the gradient done for part A. For part B, it says find the equation of the line AB. So the equation of AB, we're going to use it in the following form: y minus y1 equals m x minus x1, where m is that third value that we've just found, the gradient of the line, and y1 and x1 are either a's coordinates or b's coordinates. It's up to you which one to choose. It really doesn't matter. I'm going to choose b's because they're both positive, so I don't have to worry for any minus making a plus. So I'm going to get y minus 5 is equal to 1/3 x minus 8. I don't like this third bit here, so I'm going to times this side by 3 to get 3y minus 15 is equal to x minus 8. And then we tend to get everything all on one side, and I tend to try and keep my x positive. It doesn't really matter though, it's still the same thing, it's equivalent. So I'm going to have x minus 3y, and then that minus 15 coming over will become a plus 15, so I'm going to get a plus 7. Okay? Part C. So part C says the line AB is extended to the point C so that B is the midpoint of AC. Find the coordinates of C. Okay, so let's have a quick read of that again and try and work out what's going on. So the line AB is extended to the point. So the best to draw a picture here. Okay, so I know the coordinates of A were like -1, 2. I never draw the axes in whenever I draw my picture, just some generic idea of it. So that's A. And then B was 8, 5. So it would have been further across and up a bit higher. So there's 8, 5, and that was B. So that's my line AB from there to there. And it says that this line is extended so that B is the midpoint of AC. So C would be all the way over here somewhere, and that is the middle. Okay, so I don't really know what its coordinates are. I haven't quite got enough room for what I've done. It's just to give me the generic idea. So I know that the x coordinates, so if we call C's coordinates x1 and y1, I'm going to say that for B to be the midpoint, the A's x coordinates -1 plus C's x coordinates, so I'm going to call that x1 divided by 2 must be equal to B's x coordinate, which was 8. And then it'll just be a case of solving that as an equation. So taking the over 2, so get -1 plus x1 equals 16. Take the -1 over and get x1 is equal to 17. Then I'll do exactly the same for y coordinates. It'll be 2 plus don't know C's coordinates, so y1 over 2 is equal to B's y coordinate, which was 5. So take the 2 over, we get 2 plus y1 is equal to 10, so y1 is equal to 8. So C's coordinates must have been 17, 8. Okay. Next bit of information I'm given. It says the line L is parallel to AB. So if it's parallel to AB, that means its gradient is the same. This line L intersects the y-axis at the point 0 minus 1/6, and the x-axis at point D. So then it's given me a load of things to do for part D. So do I want to try and draw a little picture? You can do if you want. I'm going to leave it for now. And what am I going to start to fill in? It says write down the equation of L. Okay, so the first thing I can say is y minus y1 equals m x minus x1, and that's for the equation of L. So I should have said that by here. Equation L. Now, in terms of what we need to know its gradient, which we do know because it's parallel to AB, its gradient is the same. So I can put in a third there. And because what we're told that it goes through the point 0 minus 1/6. So I can say y minus 1/6. And then I can say x minus 0 goes in there. And then I can start solving this. So I'm going to get y plus 1/6 is equal to 1/3 x. Don't like this over 3 bit. I don't like the over 6 bit. So I'm going to times everything by 6. So I'm going to get 6y plus 1 is equal to 2x. And then I'm going to keep the x positive and say 2x minus 6y minus 1. So that's my equation for L. It says find the coordinates of D. Okay, now what I was told, it said that at the x-axis, says the line L intersects the y-axis at that point 0 minus 1/6 and the x-axis at the point D. Now, if we think of what the axes would look like, if I've got a line, just say it looks like that generically, if it is intersecting the x-axis, we know something about the y-coordinate. We don't know what the x-coordinate is, but we know what the y-coordinates be. It must be 0. Okay, and we know the equation of this line was this thing here that I just worked out. So I can say at D, y is equal to 0. Therefore, 0 is equal to 2x minus 6. I'm going to change the y-coordinate to 0 and then minus 1. So I'm then going to get 2x minus 1 equals 0. Then I'm going to get a half is equal to x. And I'm hoping that's right. Yep. Okay. So D's coordinates would have been a half, 0. Okay. And then finally it says find the length of AD. Okay. So to find the length of AD, you can use the formula, which is this big square root of diff in y's squared plus diff in x's squared, and then sub it through that. I'm more a fan of plotting it myself. If we're talking AD, if I look at what A's coordinates were, they're minus 1 and 2. And then D's coordinates, I just worked out, was a half 0, so it would be somewhere around here. Half 0. That is just a right angle triangle. So I'm going to try and use a bit of Pythag there. If I'm on minus 1 and I've gone to a half, that's a distance of 1.5. And if I'm on 0 and I've gone up to 2, that's a distance of 2. So it's going to be 1.5 squared plus 2 squared is equal to AD squared. So I know that 1.5 squared, you should know hopefully 15 squared is 225. So 1.5 squared should be 2.25. But if you didn't, you just go and do some working by the sides. Plus, and I know 2 squared is 4. So that's AD squared. So AD squared is equal to 6.25. So AD is equal to root of 6.25, and I'm pretty sure that's 2.5. Okay. In terms of would you have to get it cancelled down? Ideally, yes. You could maybe turn that into a top-heavy fraction to maybe see what it's like if you see any square numbers. For instance, the 2.5 is a quarter, so it's 6 1/4. So that would be 25 over 4, and then the root of 25 is, and then the root of 4 is 2, so 5 over 2 is 2.5. Yeah, so that is definitely right. Okay. Okay, then number 2. Okay, make sure you can see what I'm doing. Okay, number 2. So we're given root 2 over 10 minus 7 root 2. And I know that to solve this, I need to times by the denominator again, but it's not quite the same denominator. All you do is change it to its opposite sign. So if that's a minus, that becomes a plus, and vice versa. If that's a plus, that wouldn't become a minus. But whatever you do to the bottom, you must also do to the top to get it to remain equal. Okay, so the top is going to give me 10 root 2 plus, and then it's going to be 7 root 2 times root 2. So that's just going to be 7 times 2, which I'll deal with that in a moment. And then on the bottom, I'm going to get 100. I'm going to then get plus 70 root 2, and then minus 70 root 2. That always happens. They always cancel. And then I'm going to get minus 7. That's going to give me a minus 49. And this will be root 2 times root 2, which again is just normal 2. So 49 times 2. And now I'll start to neaten that up. So I get 10 root 2 plus 14 all over. It's going to be 100 minus 98, isn't it? So that's 98. So that's going to become 2. And then I can halve both of those. So I get 5 root 2 plus 7. Okay. Okay, part B, give me 1 second. Let's just start that. Oh, no, part B, sorry. Question 3. Okay, number 3. So it says, given that the quadratic equation, and it tells you it's 2x squared plus, mess that up, sorry, plus 3k minus 1x, and then plus 3k squared minus 1 equals 0. Has 2 distinct real roots. So this is telling me all about the discriminant. So the best way to answer this is to identify what A, B, and C are straight away. So A is equal to 2, B is equal to 3k minus 1, and C is equal to 3k squared minus 1. Okay? Now, if we're told it has 2 distinct real roots, 2 real roots, then you should know that the part from inside the square root in the quadratic formula, this b squared minus 4ac, for that to give 2 answers, it's got to be positive. If it was equal to 0, it'd just be 0, and that'd be 1 answer. And if it was negative, you can't square root it, so you couldn't get an answer. So we'd say it's less than 0. Okay, that's when you have no real roots. So what I need to do now is change that a, b, and c coefficient. I need to square it, then take away 4 lots of a and c. So that's going to be 3k minus 1 squared minus 4 brackets 2, and then 3k squared minus 1 is greater than 0. Now, it's best if you take your time here. You don't have to. If you think you know how to do it, fine, go ahead, do it. But it's not a bad idea to actually go and write this bit out. 3k minus 1 times by itself, 3k minus 1. So 3k times 3k is going to give me 9k squared. I'm going to get a minus 3k. I'm going to get another minus 3k. I'm going to get a plus 1. But it's very common that people forget about this term here, okay, or these terms. Minus, and I'm going to expand that to get 8. I'm going to take this in slowly, actually, because otherwise I'm going to mess it up. You can see me rushing and getting it wrong, okay? Okay, so now I'm going to expand and start to simplify. So I'm going to get 9k squared minus 6k plus 1 minus 24k squared, and then plus 8 is greater than 0. Okay, so what's that going to give me next? That is going to give me 9k squared minus 24k squared is going to give me minus 15k squared. I've got no other k terms, so I'm going to have a minus 6k. And then, sorry, just so you can see what I'm doing. Then I'm going to have plus 1 plus 8 is going to give me plus 9 is greater than 0. Okay, then, so starting to look what they had now, do you notice how my greater than sign is the opposite way around to theirs? And that's really good news because my k squared is minus. So what I'm going to do is I'm going to times everything by minus 1. But your rules of inequalities, you should remember that if you times anything by minus with an inequality sign, it will flip its sign straight away. So that is going to give me 15k squared plus 6k minus 9. Okay, and again, it's still not quite what they had in the original thing that says show that it's this. It says it's 5k squared plus 2k minus 3. But hopefully you can spot that this is all divisible by 3. We get 5k squared plus 2k, and then minus 3, which is less than 0, as required. That's exactly what they wanted us to have, and that's what I've proven that you've given. What I could have done here, instead of times by minus 1 and dividing by 3, I could have just divided by minus 3 and it would have done the same job as well. Okay. It then says, find the range of values satisfying k for this inequality. So what we need to do is factorize it. And the way I like to factorize is I times the 5 by the minus 3 to get minus 15. And then I look at what the middle term is, the plus 2 here. I say it adds to plus 2. So I'm thinking of a pair of numbers that times to minus 15 and add to 2. Well, that has to be a plus and a minus. And then numbers that times together to make 15, 5 and 3, plus 5 take away 3 is indeed 2. So that is my combination of numbers. Now, the way I like to factorize is I drop just the squared term from k. So put 5k and 5k is less than 0. And then the plus 5 goes in one bracket and minus 3 goes in the other bracket. But what I must do is I must cancel down if possible. Now, I know it will be possible because 5k times 5k will give me 25k squared. So this one here, you can see I could divide both of those by 5. And then this one here can't be cancelled down. So it literally stays the same. So I get two solutions for what my roots are. I get k equals minus 1 or k equals 3/5. Now, what that's telling me is that if I had a graph, like a quadratic, like that, I now know what those two intersections are on the axes. One is minus 1, and the other one is 3/5. These two answers from here and here. Now, I'm interested in where that is less than 0, and it's less than 0 where those two are joined up. So what I'd say is that the rules, or the solutions, what does it say, the range of values for k would be minus 1 is less than k is less than 3/5. Okay? Okay, number 4 is differentiation from first principles. I'm probably going to skip the proof. We've done loads of those in class now. So I'm going to say first principles proof. I'm going to go straight to part B. It says differentiate 3x to the 4, or over 4, minus 7x to the third with respect to x. Now, one of those is very easy to differentiate. One of them is really hard because it's not up on the top. We've got to get that x to the power of 4 up on the top. So to do that, we're going to change it to 3x to the minus 4, and then leave that as 7x to a third. And when we differentiate, we times by the power and reduce the power by 1. So the answers that we should be getting are minus 12x to the minus 5, and then we should be getting minus 7/3 x to the minus 2/3. Okay, now in terms of what that is, it looks a bit messy. It's absolutely fine to leave your answer as that. Okay, there's no need to do anything extra to that bit there. Okay, number 5, binomial theorem. So brackets 1 plus root 3 to the power of 5 in the form a plus b root 3, where a and b are integers whose values are to be found. Okay, so if I'm going to expand that, I'm going to want to do Pascal's triangle. So I'm going to start doing that by here. That's the one I want because it's the 5th power, okay? So 1, 5, 10, 10, 5, 1. Okay, so I'm going to put in all of those coefficients first. I'm going to leave a bit of a space, and I'm going to probably take up 2 lines as well. I tend not to rush this, because if you rush it, you'll mess it up. Okay, so the first one, I'm going to get 1 to the power of 5, and I'm going to get effectively root 3 to the power of 0. So if it's the power of 0, what's the point of putting it in? It's just going to go to 1, waste of time. The next one is going to be 1 to the power of 4, and then it's going to be root 3 to the power of 1. These two numbers should always add up to that 5. Then I'm going to get 1 cubed, and then root 3 squared. And then I'm going to get 1 squared, and then root 3 cubed. And then I'm going to get 1 to the power of 1, and then root 3 to the power of 4. And then finally 1 to the power of 0, which is nothing. Well, it is something, it's 1, but I'm not going to bother writing it in. And then root 3 to the power of 5. Okay? Okay, so let's start expanding out these terms. I'm going to get 1 to the power of 5 is 1, times by 1 is 1. I'm going to get 5 times 1, and then times by root 3. So I'm going to get 5 root 3. Now here, I'm going to get root 3 squared, which is root 3 times root 3, which is 3. I'm going to times that by 1, which is still 3, and then I'm going to times that by 10, which is plus 30. And then that's it, there's no root 3 or anything because root 3 squared cancels out. Now this one here, root 3 cubed, is going to be root 3 times root 3, so we already know that's 3, but then we times that by root 3 again. So we're going to have 3 root 3 for that answer. Times it by 1 times it by 10 gives me plus 30 root 3. This one here, root 3 to the power of 4, is going to be root 3 times root 3, which is 3, times by root 3, times by another root 3. So that's going to be 3 times 3, which is 9. Times that by 5 will give me plus 45. And then finally, this root 3 to the power of 5 would be the root 3 to the power of 4, which we've already said is 9, times by root 3 again, which would be 9 root 3. And then finally, I'm just going to simplify all those terms. So I've got 1 plus 30, 31, plus 45, so what's that, 76? 76, and then 5 root 3 plus 30 root 3, so it's 35 root 3 plus the 9, it's going to give me plus 44 root 3. Okay? Question 6 came up in our mock, very similar question, and loads just messed that up. So very important we know how to do this one. So it says x squared plus 1.4x minus 8.51 may be expressed in the form x plus p squared minus 9, where p is a constant whose value is to be found, hence solve this quadratic equation where it's equal to 0. Okay, so what we do is we halve this coefficient here, so we're going to get that. But then you must always take away whatever this is squared. Now 7 squared is 49, so 0.7 squared is going to be 0.49. So we're going to have 0.49 there, minus 8.51. And then I'm going to have x. And then 0.49 minus 0.49 minus 8.51 is going to give me minus 9. There's a big hint in the question it was going to do that. Okay? So therefore, to solve this thing, this x squared plus 1.4, x minus 8.51 equals 0, I'm going to change it to its completed the square version. And then I'm just going to solve it as an equation. So I'm going to take over the minus 9. It's going to become a plus 9, so just 9. Then I'm going to take this squared over, and it will become, be careful with this bit, plus or minus 3. So my one answer is going to be x is equal to x minus 0.7 is equal to minus 3. So x is equal to minus 2.3. Or I could have taken the positive, so x minus 0.7 is equal to just positive 3, so x is equal to 3.7. Okay? Okay then, number 7. Okay, number 7 says find the remainder when x cubed minus 3 is divided by x plus 2. So x cubed minus 3 is divided by x plus 2. That means we want to sub in f of minus 2. So all we have to do here is do minus 2 cubed minus 3. Minus 2 cubed is minus 8, minus 3 is then minus 11. So that's what the remainder is, minus 11. Okay, part B tells me to solve the equation 6x cubed plus x squared minus 11x minus 6 equals 0. So from here, I need to go and find a factor, and the way that you find a factor is you just start subbing in some numbers. Best one you can start off with is 1. See if you get anywhere at all. That if it equals 0, it's a factor. We can start dividing it in. So I'm going to get 6 lots of 1 cubed plus 1 squared minus 11 lots of 1 minus 6. I'm going to see what that is. So that's going to give me 6 plus 1 minus 11 minus 6. And I can quite clearly see that's not going to be equal to 0. I'm not even going to bother finding out what it is. It's not equal to 0. And then the next one to choose, don't ever discount its minus number. It could be that that one works. So I can get 6 lots of minus 1 cubed plus minus 1 squared minus 11 times by minus 1 and then minus 6. Now that's going to give me minus 1 cubed is going to give me minus 1 times that by 6 is minus 6. Minus 1 squared is going to be plus 1. Minus 11 times by minus 1 is plus 11 and minus 6. And I can quite clearly see here plus 1 plus 11 is 12. Take away 6 is 0. So therefore, x plus 1 is a factor. Therefore, x plus 1 is a factor. Okay, so we've got this 6x cubed plus x squared minus 11x minus 6 that we're trying to solve. And the way that we're going to start doing that now is doing x plus 1 there and trying to work out what went inside these brackets. Now, to make this 6x cubed, I've got the x. This must have been 6x squared. That's the only way I could have made x cubed there if that number there was 6x squared. And similarly here, if that's a minus 6 there and that's plus 1 here, the only way I can make that minus 6 is to have that as minus 6 by there. Okay? Now, in terms of what I want to make next, I can either make the plus x squared term or I can make the minus 11x term. I'm going to go with the x squared term. Okay? I tend to always go with that. It doesn't matter though. Okay, this is going to be a quadratic. It's going to go in the form of ax squared plus bx plus c. And I already know what the a is, I already know what the c is, I just don't know what the b is, but I know it'll be something x. So I'm trying to make these x squared terms. So I know that this plus 1 times by the 6x squared will give me plus 6x squared. I know this x times by the x term will give me something x squared. And I know overall I have to make plus x squared. So what number has that got to be? For 6x something else to make plus x squared, well, it's got to be minus 5x squared, because plus 6x squared minus 5x squared is x squared. Okay, I have got a link to a video of me explaining this that's somewhere on my site. So that means that x times by minus 5x must have made that minus 5x squared. And all I need to do now is factorize that second bracket. So I'm going to do the same trick as I did before. I'm going to do 6 times minus 6, which gives me minus 36. I've got to make minus 5. So I've got to think of pairs of numbers that times together to make 6 and times together to make minus 36 and add to minus 5, and I think it is 4 and minus 9. So then I've got x plus 1, and I just drop just the square term originally from the 6x squared from here, and then plus 4 is going in one bracket, minus 9 is going in another bracket, and that is equal to 0. And then I must cancel down as and when I can. So I'm going to get 3x plus 2, and then I'm going to get 2x minus 3 equals 0. And finally, I can say, therefore, x equals minus 1, x equals minus 2/3, or x equals 3/2. Okay. Number 8. Okay, so number 8. It says the curve y equals x squared minus 6x plus 7. The point P, whose x coordinate is 5, lies on the curve. Find the equation of the tangent to the point C. So that curve is going to look something like that. We know at the x coordinate being 5, we draw a point and then we draw a tangent to that, and we want to find the equation of this thing. Okay, so to do that, I need to know, I'm going to use y minus y1 equals mx minus x1. I know what x1 is, it tells me in the question it's 5. I don't know what y1 is, and I don't know what the gradient is, so I need to find both of those things there. Let's do the y coordinate first. So y coordinates must have been, if x is 5, if x equals 5, then y is equal to 5 squared minus 6 lots of 5 plus 7. So that's going to be 25 minus 30 plus 7. 25 plus 7 is 32. Take away the 30, so y is equal to 2. So my coordinates are going to be 5, 2. That's what that point is there, 5, 2. And now I need to find out what the gradient is. And the way I find the gradient with a quadratic or with a cubic or anything that's a curve is I differentiate it. Okay, so I'm going to get 2x minus 6 and say when x equals 5, dy by dx is equal to 2 lots of 5 minus 6. So 2 lots of 5 being 10, take away the 6 being 4. Okay, so now I can put it into this y minus y1 nonsense. Okay, so equation of, what have they called it? Equation of tangent is going to be y minus 2 is equal to 4x minus 5, and that's going to give me y minus 2 equals 4x minus 20. And if this is in the form y equals, we can write it in the form y equals mx plus c, or you can write it all on one side, it doesn't really matter. So I'm going to take over the minus 2 over it, become a plus 2. I'm going to get 4x minus 18. Okay. Part B says L has the equation y equals a half x minus 2. Find the coordinates of the 2 points of intersection of C and L. Okay, so C was the curve, and this line is a half x minus 2. Now, if it's looking for me to find points of intersection, it's got a curve there and a line going through it like that. Okay, so that's my C, that's my L. And the way that we solve that is through simultaneous equations. So we know from before that C was equal to x squared minus 6x plus 7. And we know that this L is y is equal to a half x minus 2. And we're interested in where they meet. So we're interested where they're equal to each other. They're equal here and here. And I need to substitute this value of y being a half x minus 2 into this one here. So I'm going to call this 1, call this 2. I'm going to say sub 2 into 1. So I'm going to get a half x minus 2 is equal to x squared minus 6x plus 7. I'm then going to rearrange that to form a quadratic. Before I do it, actually, I'm going to double everything. So I don't like this half x. So I'm going to get x minus 4 is equal to 2x squared minus 12x plus 14. And then I'm going to turn everything onto one side. So I'm going to get 2x squared minus 13x and then plus 18. Okay, so from there, I now need to factorize yet again. So it's really important you can factorize quickly when it comes to C1. So 2 times 18 is, what's that, 36? And then minus 13 there. Okay. Now if they times together to make a positive, but they add to make a negative, the signs must both be negative. So what numbers times the 36 and then take away to minus 13? I've got minus 9 and minus 4. So I'm going to have 2x minus 9 and 2x minus 4 equals 0. And then I'm going to leave that as 2x minus 9 because I can't cancel it, but this one does cancel to x minus 2. So my coordinates, my x coordinates of intersection are 9 over 2 and y equals, and I'll find y in a second, and x equals 2. When x is 9 over 2, that's 4.5. I'm going to sub it into 2, which is what's by there. So a half times 9 over 2 would be 9 over 4. I might think of that as a number actually. So 9 over 4, and then take away 2. So that's going to be 2 1/4, take away 2. So y is just going to be equal to 1/4. I'm hoping that's right. Yeah. So I've got 9 over 2 and 1 1/4. And then here, when x was 2, it's much simpler. So half of 2 is 1, take away 2. So y is equal to minus 1. So the other set of coordinates is 2 minus 1. Okay. Just check that's fine. Yep, that's fine. Okay. Part 2 says verify that L is in fact the normal. Verify that L is in fact the normal to C at one of these points of intersection. Okay. So it's requiring you to know something about the gradient of this line here. We know this is equal to half the gradient of this line. It wants to know that if I draw a tangent here or a tangent here, that it's going to be minus 2, because a half times by minus 2 would be minus 1. So what I need to do is I need to find the gradient of these points of intersection. Okay, so again, I'm going to have my C coordinate, my C value here, which is C was y is equal to x squared minus 6x minus 7, and we know it's differential. So you can't see what I'm doing here. We know its differential was 2x minus 6. Okay, so I'm going to do the easy coordinates first. I'm just going to choose 2 and minus 1. At 2 minus 1, dy by dx is equal to 2 lots of 2, because the x coordinate is equal to 2, minus 6. So dy by dx is equal to 4 minus 6, which is minus 2. Now that's exactly what I've just said. I'm going to say as grad of L equals a half, and grad of tangent at x equals or at x equals 2 is equal to minus 2, as minus 2 times by a half is equal to minus 1. This shows that L is the normal to C. Okay. Question 9. Transformations of graphs are usually pretty straightforward. So we've got this graph here. I'll draw the original. So here's the original graph. So we've got something coming around like that, and we've got minus 3, 0 there, and we've got 5, 0 there, and we know this minimum point here is 1 minus 4. Okay, so for part A, it wants me to do f of x plus 3. Okay, so the way we've learned the rules is when it's inside, it does the opposite of what you set to the x coordinates. Okay, so that means it's moving left or right 3 units. You'd assume that it's moving 3 units on because it's saying plus 3, but it actually does the opposite of what it expects. Okay, so that minus 3 is actually going to go down 3 values, so it's going to become minus 6. That 5 is going to go down 3 to 2, and that 1 will become minus 2. So it just shifts the exactly same graph, and it's now going to be minus 2, minus 4. That's going to be minus 6, 0, and this is going to be 2, 0. Okay, and then for B, it wants me to do minus f of x. Okay, minus f of x is a reflection, and it is a reflection in the x-axis. If you're ever unsure on that, think of what x squared looks like. X squared looks like that. What would minus x squared look like? Look like that. So it's been reflected in the x-axis. Okay, so that is going to be back to the original there. So it's still going to go through exactly the same points on the x-axis at minus 3 and 0 there, and then 5 and 0 there. But it's just this point here, this 1 minus 4, will become still 1, but just positive 4 this time. Okay? And finally, question 10. Question 10, it says we've got y is equal to x cubed plus kx squared minus 9x minus 10. Where k is a constant, the 2 stationary points on the graph C are denoted by Q and R. Find dy by dx. So it says that the x coordinate of Q is minus 1. Find dy by dx and hence show that k is equal to minus 3. Okay, so we know that at Q, dy by dx is equal to 0 because it's stationary. Okay, so what I can do now is I can differentiate. I don't know. I'm overcomplicating things here. I know what Q's x coordinate is. So if Q's x coordinate, I'm going to say Q x equals was it minus 1? Yeah, Q x equals minus 1. So I can say y is equal to minus 1 cubed plus k lots of minus 1 squared. Hang on, fussing things up here. No, I was doing the right thing to begin with. Right, so differentiate that. We know this differential is equal to 0. So I need to say dy by dx is equal to, it's going to be 3x squared, and then this kx squared is going to be plus 2kx, and then minus 9. I can now put that equal to 0 because it's stationary. And then that is equal to 3x squared plus 2kx minus 9. But I know the coordinate. I know that x is equal to minus 1 here. So I can chuck in minus 1 into that. So I get 3 lots of minus 1 squared plus 2k minus 1 minus 9. That's going to give me 3. It's going to give me minus 2k and then a minus 9. I'm going to take the minus 2k over to get a positive 2k is equal to minus 6. And then I'm going to get k is equal to minus 3, which was as required. Okay, I was asked to get it to that. Okay. From there, it says find the x coordinate of R. So what I need to do now is rewrite out this original thing, but I can put in what k was. So it's x cubed minus 3x squared minus 9x minus 10. I'm now going to differentiate it and put that equal to 3x squared minus 6x minus 9. I can put that equal to 0 for stationary points. To make this easier, I'm going to divide it by 3. So you get x squared minus 2x minus 3. And then I'm going to factorize to get 3, x minus 3, and then x plus 1. So that states that x equals 3, or x equals minus 1. X equals minus 1 was q. So this x equals 3 must have been r. R must have been the one at 3. Okay? So the coordinates of r coordinates, x equals minus 3, y is equal to x cubed, so 3 cubed, minus 3 lots of 3 squareds, and then minus 9 lots of 3, and then minus 10. So we're going to get 27 minus 27 minus another 27 minus 10. And I'm hoping that's looking right. In fact, actually, I'm doing extra work that I wasn't even required to do, but it doesn't matter. I've done it now. So we're going to get minus 37 for r. So r was 3 minus 37. Okay. And then I could have done the same for q, but I've just reread the question. It's not asking me to find the y coordinates at all, so why bother wasting our time? Okay, so over to the other side of the paper, and last bit of the paper now. It says, determine the nature of each of the points. Okay, so the previous work that I've done that I need here is dy by dx. What was that equal to? That was equal to 3x squared minus 6x minus 9. So to determine the nature of these points, so I know that r was minus 1. Let me turn over and just make sure I do this correctly. What was r? R was x was equal to 3 and q was x was equal to minus 1. So the differential tells me the gradient of the graph. If I double differentiate, it tells you the nature of the points, but remember it does the opposite of what you expect. So the double differential would be 6x minus 6. So say when x equals 3, d2y by dx squared is equal to 6 times 3 take away 6, which is 18 take away 6, which is 12, which is greater than 0. So as it's greater than 0, you just assume it's a maximum, but it's actually the opposite way around. Therefore, it's a minimum. Okay? And similarly, when x is equal to minus 1, d2y by dx squared is equal to 6 lots of minus 1 minus 6. So that becomes minus 6 minus another 6, that's minus 12, which is less than 0. And again, you would assume because it's less than 0, therefore it is a min, but it's not, it's the other way around. Therefore, it is a maximum. Okay, and that is the end of the paper. I hope you found that useful, and I will do a C2 paper at some point before we go back.